control room. The room that you see in front of you is not a model or a mock-up. The room that you see in front of you is 100% the real thing. More like 99% the real thing. These plants right here, they're fake. Other than that, this is where it all happens. Since 1995, all the shuttle flights have been controlled from this room. This is, however, not the only control room we have in the building. If you were to head out this door, go down the hall, you reach Flight Control Room 1, which you can see here on the TV screen. It is the International Space Station Control Room, manned 24/7, 7 days a week, 52 weeks a year, because we always have people living and working on board the space stations. Above that room, on the third floor of this building, is the Historic Mission Control Room, first used in 1965 to command the Gemini flights, the Apollo missions to the moon. On April 12, 1981, STS-1, the first flight of the Shuttle Columbia, and 20 more shuttle flights were controlled from there until 1995, when it was closed down, retired, and restored to the way it looked back in the 60s, in its heyday, when we were sending people to the moon. At which point this room was brought online and has been controlling shuttle flights ever since. There's over 20 flight control positions here in Flight Control Room White, the most prominent of which is, of course, the flight director of flight. Affectionately known as the quarterback of the coach here at JSC, they are the boss of all bosses. No human being on the face of this earth or above it, not the commander of the spacecraft in flight, not even the President of the United States, can override a decision made by the flight director while the flight is in operations. The flight director is in charge of crew safety and mission success. The right-hand man or woman, whichever the case may be, is Capcom, or Capsule Communications. Keep the name out of tradition. The chair at Capcom always has been and always will be filled by an astronaut, and that is because it takes one to talk to one. They are like pilots, have their own shorthand language, their own set of colloquialisms they like to use, so it's a lot easier to have an astronaut talk to an astronaut rather than an astronaut talk to a ground control engineer. That also helps to have an astronaut there to prioritize the order of communication, because more often than not, more than one console wants to send a message to the astronauts, so it's important that they get the order right of what's most important to the least important. Directly in front of Capcom, you have FAO, Flight Activities Officer. This person has the tremendous responsibility of making sure that the astronauts go to bed and brush their teeth on time. When you're traveling in space, on the space shuttle, space station, or Russian Soyuz, you're in what's called low Earth orbit. In order to maintain orbit at this altitude, you have to travel at a speed of 17,500 miles an hour, or roughly 5 miles in 1 second. Going at that speed, you get to see 16 sunrises and 16 sunsets in a 24-hour period. You also pass the international date line 16 times in a day. So if that doesn't mess up your circadian rhythm, I really don't know what will. Therefore, the FAO will keep track of your sleeping wake schedule for you, telling you when it's time to go to bed and when it's time to wake up. Also, they keep track of the flight plan, a sequence of events written out for the 2 weeks you're going to be in space. The shuttle only has 2 weeks, so it's very important to have everything laid out what you're going to be doing so you can achieve all your mission objectives and come home safely. On board the space station, it's a bit different. You still have a flight plan, but you're out there for anywhere between 3, 4, or even 6 months, depending on your assignment to your position in the expedition crew. Sorry, I can't talk right now. Now, despite the fact that you're in space between a quarter of a year to about half a year, time in space is always precious. No matter how long you're up there, it's hard to send things into space, and once you're up there, there's a lot of important work to be done. Now, the schedule is a little bit less confined and constricted the way it is in the shuttle mission. When you're on board the space station, you work kind of the way we all do down here on the planet Earth, 9 to 5. A week on board the ISS would look something like this. Every day that you're up there, you have to maintain the spacecraft systems, making sure everything works, and then exercise 2 hours every day to save on muscle and bone atrophy. You're in weightlessness, so you have to counteract those negative effects through the exercise. After that, Monday through Friday, you're going to be doing your job. Roughly 1,000 scientific experiments are on board the International Space Station that need to be monitored and conducted. And they've been developed by one or more of the 16 countries that are all working together to operate the ISS. This makes the International Space Station the largest peacetime collaborative effort ever undertaken in all of human history. The experiments run the gamut from studying our own human physiology to physics, chemistry, agricultural research, and medical science. And all of the experiments can only be performed in space, in microgravity. A very good example of this is the growth of protein crystals. Now, yes, they can be grown here on planet Earth, but they're distorted by Earth's gravity. When you grow them in space, however, there is no gravity to distort their growth. And all of the measurements we would get from the experiments are by far more accurate when you conduct them in space. With this research conducted on the space shuttle and now the space station, as well as other types of research performed here on planet Earth, there have been breakthroughs in the medical community when it comes to the treatment for and the medications for a disease known as cancer. May one day hopefully help in finding a cure for that disease. So that's just some of the stuff you do on board the space station. On a weekday, On the weekends, they're considered your day off. You can kind of do what you like. You can email friends, telephone home, update your iTunes, read a book, watch TV, watch movies. They get satellite in space, by the way, not cable. They also like to look out the window. Now, I know this sounds kind of mundane and a little bit low-tech, but take my word for it, ladies and gentlemen, they have the absolute best view in the entire solar system. Over here on the left wall, you can see 63 mission patches, which represent 63 of the 64 flights that have been controlled from this room. Our next mission, STS-133, will be going into space in September to the International Space Station to permanently install Leonardo, or the Multi-Purpose Logistics Module, which we have used as a cargo container to ferry up materials that will be installed in the interior of the space station. Now, with the shuttle program coming to a close, flight after next, we are going to permanently install Leonardo as extra cargo space, or closet space, as the astronauts like to call it. As the launch date approaches, fingers crossed, no weather delays, no equipment delays, a nice, safe, and successful flight to the shuttle Discovery, your crew. There's another flight that was controlled from here that is near and dear to me for a couple of reasons. It's STS-125. And the reason why I like to talk to every group about it is because, well, it was our fourth and final trip to the Hubble Space Telescope, and let's face it, the Hubble's really cool. They returned home safely to the Earth. There was a letter waiting for them from the Goddard Space Flight Center and the Space Telescope Institute. These are the folks in Maryland who actually run the Hubble and do the research. And they said thank you to the crew and everyone who worked in STS-125, which, by the way, are thousands upon 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 thousands of people who all work together as a team to make every shuttle flight possible. Scientists, astronomers, and engineers who wrote this letter are now speculating and hoping that the Hubble is powerful enough and sensitive enough to look so far across space and time that we are going to be able to study in further detail dark energy, or at least its effects that it has in the universe. I mean, right now, all we really know about dark energy is we believe it's the driving force behind the continued and accelerating expansion of the universe. That's all we know. We would like to learn more. We would like to learn more about the formations of early stars, early galaxies, and even the early universe as a whole. Also, more about the process that took place over billions of years that brought the universe from its tumultuous past to where we are today. Maybe, just maybe, get one or two clues as to what might happen to the universe in the next couple billion years. Now, these are huge questions and enormous mysteries that we are trying to get the answers to. I will promise you this: we will not answer them all. And even if we answer just one of them partially, it will raise dozens and dozens of questions.
Grabe, aray. Ganat lang ko ito yung video. Wait lang.
Venz. Up more, like that, up. Like that, like that. 1, 2, 3, go. Oh, one more.
Ate.
More mga engines ni ate. 1, 2, 3, 4, 5 engines.
5.
5 engines, that's how big that.
2.
Makasud ka ba? Dako pa sa tao. Mga 5 engines.
Bebe, Venz. Hello.
Dapat din mo work si Kuya Darwin, kay engineer naman siya.
Bitaw.
Engineer na
Unsa ni ate? Unsa na ngayan? Ate, unsa na ngayan?
Mao ba?
Mao ba?
Yung what's on the grass day. Pwede ba na diha?
Bata man siya, okay na siguro ate. Ato, sa kata dito.
Oh my goodness, hey, you can go there.
Lulu. Biyaan na dyan mo. Ato na siya. Hindi na dyan niya kaya, te. Ato na dyan siya, oy. Kaya ba siya dugmoon, ate? Oo. Mag-ch-ch-ch.
Venz, you can't go up there. You can't step on the grass.